Hello, and welcome to the instructional series. In this video, I am going to show you the various capabilities of 3D Experience platform that allows you to refine the concept shapes of assemblies, validate and reconstruct them for additive manufacturing process. This video will teach you how to define the functional specifications, analysis inputs, optimization targets and constraints. A satellite bracket is used to create this intuitive workflow. Now, let's get started. To analyze and optimize a design space, we must first define some input parameters. In this activity, we will set up a design space. By default, a design space created with CUTIA is usually made of single volume. In order to define functional volumes, the design should be split into several subvolumes, usually by cutting with a surface. A geometry can be split in order to create partitions by a plane, another body or a surface. Let us now create partitions on the satellite bracket design space. It is highly recommended to distinguish the reference design from the partition solid. Let us now create the partition around the bolt of the geometry with 3 mm offset value. Let us now create simulation object. Here in the Exploration Assistant panel, let us first define design space. Now, let us select the functional region. Here all the holes for bolts must be selected as a functional region. Next step is to mesh the geometry. Here, let us specify the value for mesh size representation as 3.33 mm. Now, we will define various loads, restraints and virtual connections on the part. Let us start by applying remote force. Select the faces of all the bottom holes and apply force of 3000 Newton in negative Z direction. Similarly, apply force of 100 Newton in positive X direction. Next, let us create load case for the respective load. You can create multiple load cases and apply different loads and restraints in the load case manager. Here we have created 2 load cases with different inputs. Let us apply virtual bolt connections on the edges of the hole. Observe that the head diameter is defined automatically as per the selection. The axial and shear stiffness can be defined in the bolt editor dialog box. Similarly, select the virtual bolt and replicate the virtual bolt to another locations. Next, to generate practical concept shape, it is necessary to set up the optimization model by defining target and constraints related to its performance. Let us start by defining optimization target. For this scenario, we will set the target of maximizing stiffness with 15% target mass of the design space. Now, let us specify the shape control options. To create designs that can be easily manufactured by a defined manufacturing process, you must use the specific shape controls for that process. The symmetry option imposes symmetry around a selected plane for the resulting conceptual shape. Select YZ plane and click OK. Now, let us compute a shape. The computation time depends on the complexity of the scenario and the system configuration. The computation is now complete. We can observe the data related to the optimization in the Summary tab. Let us now see how to visualize the results of the computation. First, we will define the required density for the concept shape. The Scale Shape slider can be moved to change the ISO value. Editing the ISO values updates the optimized model in the work area. To show the surface between elements that will be retained and the elements that will be removed. The values of residual volume and mass are updated for different ISO values. For this activity, let us set the slider at 50. Let us now generate the concept shape. Now let us move towards a structural validation on the conceptual shape. Let us select a new shape validation option to create a validation case. Let us now run a simulation for the selected validation. The results are displayed in the plots panel. Let us now run an animation to study the variation in the contours with the steps. Thank you for watching this video.